Hello guys, so today we'll learn about the heap data structure. So what is a heap? A heap is a tree-based data structure in which the nodes of the tree are assigned some value, and the values of these nodes of the tree follow a specific order of property. Now this specific order of property that the values of the nodes of the tree follow is called the heap property. Now based on the type of tree used in the heap and the heap property, we have various kinds of heaps. For example, binary heap, binomial heap, Fibonacci heap, and so on. However, the most commonly known heaps are binary heaps, and for this video series, we'll be focusing on binary heaps. So what is a binary heap? Now we know that a heap is a tree-based data structure in which the values of the nodes follow some specific heap property. So what kind of tree do we use in a binary heap? In a binary heap, we use a complete binary tree. What is a complete binary tree? It's a binary tree in which all levels have full set of nodes except the last level, and in the last level, the nodes are to as left as possible, right? So we have covered binary trees and its classification in more details in our previous videos. So you can click on the I button on the top to see our video series on binary trees. Alright, so now let's move on to the heap property. So based on the heap property, we have two kinds of binary heap, a min heap and a max heap. So what is the heap property in min heap? In min heap, the value of the node is less than or equal to the value of all its child nodes. So let's take an example. So here, let's look at this node, right? What are the child nodes of this node? The child nodes of this node are 4 and 9. The value of this node is 2, which is less than the value of 4, and 2 is also less than 9. So the value of this node is less than the value of all its child nodes. So this node follows the min heap property. Also, now let's look at this node 4. 4, the 8 is a child of 4. And 4 is less than 8. 6 is a child of 4 and 4 is also less than 6. So 2 follows the min heap property, and here 4 also follows the min heap property because the value of 4 is less than the value of all its child nodes. All the rest of the nodes, which are 8, 6 and 9, do not have any children because these are leaf nodes, so they follow the min heap property by default. So this tree, is this a complete binary tree? Yes, this is a complete binary tree because each node has at most 2 children, so it's a binary tree. All the levels but the last level have full set of nodes. Here this level has 2 nodes, which is the full set of nodes for this level. And in the last level, all nodes are to all left as possible. So this is a complete binary tree in which all the nodes follow the min heap property. So this is a min heap. Similarly, in a max heap, the value of the node should be greater than or equal to the value of all its child. So let's look at some more examples. So here let's look at this example. Here 1 is less than 4. Let's put the less than symbol. 1 is less than 7. So 1 here follows the min heap property. Now let's look at node 4. 4 is less than 6 and 4 is less than 8. So 4 also follows the min heap property. 7 is a leaf node, so it follows a min heap property. 6 is a leaf node. Let's look at this. 8 is less than 10 and 8 is less than 9. So this also follows the min heap property. 10 is a leaf node and 9 is a leaf node. So all the nodes in this tree follow the min heap property. But is this a complete binary tree? It is not a complete binary tree because in the last levels, the nodes are not to as left as possible, right? Because we are missing the nodes here and here. So this is not a min heap. Now let's look at this example. Let's look at node 5. 5 is less than 7. 5 is less than 10. Now let's look at node 7. 7 is less than 9. But 7 is greater than 4. So 7 here does not follow the min heap property. So this is not a min heap. Now let's look at this example. Let's look at node 4. 4 is less than 10, 4 is less than 6. For node 10, 10 is less than 12 and 10 is less than 14. For node 6, 6 is less than 8 and 6 is less than 90. For node 12, 12 is less than 19 and 12 is less than 40. 14, 14 is less than 18, 14 is less than 17. And all other are leaf nodes. So in this tree, all the nodes follow the min heap property. Is this a complete binary tree? Yes, this is a complete binary tree because in all the levels, this level has all the nodes, this level has all the nodes, and in the last level, all nodes are to as left as possible. So this is a min heap. Now let's look at this example. From this example, we don't need to check the heap property first. By seeing at this example, we can see that in the last level, the nodes are not to as left as possible because we are missing this node here. So this is not a complete binary tree. And since this is not a complete binary tree, it is not a min heap. Now let's look at this example. Is this a complete binary tree? Yes, this is a complete binary tree. Now let's check the heap property. For node 1, 1 is less than 4 and 1 is less than 6. For node 4, 4 is less than 9. So this also follows the min heap property. So this is a min heap. Now let's look at some examples of max heap. So in a max heap, the value of the node is greater than or equal to the value of all its child nodes. So in this example, let's look at node 18. The child nodes of 18 are 15 and 5. And 18 is greater than 15 and 18 is greater than 5. So it follows the max heap property. Now for node 15, 15 is greater than its child 8 and 15 is greater than 1. So 15 also follows the max heap property. For node 5, 5 is greater than 2 and 5 is greater than 4. 2 and 4 are leaf nodes, so they follow the max heap property. For node 8, 8 is greater than 6 and 8 is greater than 5. For node 1, 1 is less than 10. So here node 1 does not follow the max heap property. So this is not a max heap. Now let's look at this example. For node 10, 10 is greater than 9 and 10 is greater than 6. For node 9, 9 is greater than 8 and 9 is equal to 9. So in a max heap, the value of the node should be greater than or equal to the value of all its child nodes. So here 9 also follows the max heap property. And since these are leaf nodes, they also follow the max heap property. So this is a max heap because this is a complete binary tree which follows the max heap property. Now let's look at this example. Here 20 is greater than 10 and 10 is a leaf node. Also, this is a complete binary tree. So this is also a max heap. Now here, is this a max heap? This is a single node with the value 40. Now this is a single node, so this is also a leaf node because this does not have any children. So it does follow the max heap property. And this is also a complete binary tree. So this is also a max heap. Now let's look at a property of min heap. So in a min heap, the value of the root node is minimal. So let's prove this. So let's take this example. Here 4 is the root node. Now to prove that the value of the root node is minimum, what does that mean? That means that the value of the root node is less than or equal to the value of all the nodes in the tree. Right? The value of the root node should be less than or equal to the value of all nodes in the tree. Now let's take some arbitrary node in the tree. Let's take this node. And let's look at the path joining the root node and this node. So if we look at this path, along this path, the value of the parent node will always be less than or equal to the value of its child nodes because that is the min heap property, right? So here value of 4 is less than 9. The value of 9 is less than or equal to 12 and the value of 12 is less than 30. So if we go along this path, the value of the nodes will keep increasing. Thus, along this path, the starting of this path, which is 4, which is the root node, has the minimum value. And this is true for all the nodes in the tree. So if we take any other node, for example, if we take this node and we look at the path connecting the root node and this node, then also the values of the nodes from the root till that node will keep increasing. On that path as well, the value of the root node would be the minimum. Since this is true for all nodes, the value of the root node would be the minimum. So this is true for the entire tree, but this is also true for any subtree. Now let's look at this subtree. So in this subtree, the root node of this subtree is 9. Now in this subtree, 9 would be the minimum value, because if we connect 9 to any other node, the value along that path will keep increasing. So 9 is the minimum value along any path in this subtree. So 9 is the minimum value in this subtree. Similarly, in a max heap, the value of the root node would be maximum, because in a max heap, the path connecting the root and any other node in the tree, that the value along those paths will keep decreasing. So with that, we have reached the end of this video. If you found this video helpful, do like and subscribe our channel. And if you have any questions, you can leave them in the comment box below. Thank you. See you in the next video.